Today we're going to talk about extreme values of a function. That means the high and the low values. And give you, or you may have to come up with some, I'm going to give you information to get a function, or I'm going to give you a function and you have to find the extreme values. Suppose I ask you to find two numbers whose difference is 100. Whose difference is 100. Okay, and I want the product to be as small as possible. So, and whose product is as small as possible. If you're as small as possible, then you're an extreme value. Can't be any smaller. That's an extreme. So, since the numbers are not the same, because the difference is other than 0, the difference is 100, the numbers are not the same. Well, that means one of the numbers is smaller than the other. So let x equal a smaller number, and let y equal the larger number. Well, we know that the larger minus the smaller is 100. And the product is x times y. Well, what we want to do is get the product in terms of one variable. For example, if it turns out to be a quadratic, we have a way of finding the extreme values. The lowest value or the highest value. Those are the extreme values. It happens when x is negative b over 2a. Now, to do that, to get p in terms of one variable, let's solve for y by just bringing x to the other side. So y is x plus 100. And I can take this new way of writing of writing y, and put it right there. So then p is equal to x times y, which is x plus 100. And after distributing, you get x squared. X times x is x squared times plus x times 100, which is 100x. I want to know when this is the least, but it's a parabola. Instead of y equals, you have x equals, but that doesn't really matter. I want to know what the smallest value that can be, whether it's x, y, or z. It happens when the variable on the right side is negative b over 2a, where a is the number in front of x squared, which happens to be 1, the understood number. So the bottom is 2 times a, where a is 1, and there's the minus sign for negative b, and b is the number in front of x, which is 100. Well, the bottom is 2 times 1, or 2, and 2 goes into 100 50 times. So don't forget the negative sign. So x is negative 50. And the y value is x plus 100, which is negative 50 plus 100, which is positive 50. So the two numbers are y equals 50 and x equals negative 50. The difference is 100 and the product is as small as possible. Other numbers that differ by 100 would say be 101 and 1. Their product is 101. Our product was a lot smaller. You can have negative 60 and 40. Their difference is 100, but their product is negative 2400. our product was negative 2,500. Okay, it turns out that when x and y are 50 and negative 50, the difference will be 100, but their product couldn't be any smaller. If two numbers differ by 100, the product will always be bigger than negative 2,500. Except when you actually use negative 50 and 50, and you will get negative 2,500. Okay, suppose you want to find two positive numbers whose sum is 100. Find two positive numbers whose sum is 100. Okay, but that's pretty easy. You can do 1 and 99, 2 and 98, 3 and 97, 4 and a half and 95 and a half, the square root of 17, and 100 minus the square root of 17. Those are pairs that add up to 100. But we have another constraint. And the sum of their squares is a minimum. And the sum of their squares is minimum. The min. Okay, so let x equals first number, y equals the second number. The sum is 100. So x plus y equals 100. And the sum of the squares, we'll call it s for sum. Well, one number squared plus that other number squared. We want this to be as small as possible. And we want it to be as small as possible. And our constraint is x plus y is 100. Well, we can solve for x, for example, by bringing y over. That x is 100 minus y. And you bring over plus y to the other side, it becomes minus y. So this is another way of writing x, which I'm going to put in that other equation. So s is equal to 100 minus y, that's x squared, plus y squared. But 100 squared, 1 followed by 2 zeros, is 1 squared on 1, and the 2 zeros 2 times. That is 4 zeros. Minus 200y plus y squared plus another y squared. That is, we get 2y squared minus 200 plus 10,000. And I want to know when this is the least. 200 minus 200y, just like it said there. Okay, so now it doesn't matter what the letters are. Think of s as y and y as x, and it looks more normal. Y is equal to 2x squared minus 200x plus your 10,000. Well, this here is a quadratic equation where a is positive. The number in front of the square term, 2, is positive. That means it goes like this, and we can certainly find the least value. It happens, in this case, when y is, the variable, whatever it is negative b over twice a. There's the negative, I'll put b in here, I'll write the 2, and I'll put a in here. Now b is a number in front of y, including the sign. It's negative 200. And a is a number in front of the square term. It's 2. So you have positive 200 over 4, which is 50. Y is 50. Y is equal to 50. X is 100 minus y, for y is 50. the x is 50. It turns out to get the, and the sum is 100. It turns out, if you want the sum of the squares to be the least, then you let x and y be equal to one another. You let x and y equal one another. That's going to be true no matter what the sum is. The sum was k. Well, the sum of the squares be the least when you let x and y be k over 2. We let x plus y equal the sum 100 over 2 in the last problem. We let x and y equal 100 over 2, which is 50. Okay, how about this one? Find two numbers whose sum is negative 24 and whose product is a max. Find two numbers whose sum is negative 24 and whose product is a maximum. We want the product to be the largest. So you let x and y equal to two numbers. First number, second number. Well, the first line tells me their sum is negative 24. The x plus y is negative 24. The product, P for product, well, the two numbers are x and y. That's their product. The game is to get a quadratic out of this. You need to solve for x or y. Let's solve for y by bringing the x over. Y is negative x minus 24. So P is x times negative x minus 24, which is negative x squared minus 24x. And we would like, now this is a negative x squared. It's a negative quadratic. It goes like this. So yeah, we can find the largest p-value. P is the height. Okay, and that happens when x is equal to negative b over 2 times a. B is the number in front of x, negative 24. A is the number in front of x squared, negative 1. This here is just 24. Negative 24 divided by 2 is negative 12. The x is negative 12. And we'll get y from this rule. Y equals negative whatever x is minus 24. X happens to have its own negative sign. So y is equal to positive 12 minus 24. If you read this backwards, that is not 12 minus 24, but 24 minus 12, you get 12. But if you read it backwards, you have to change the sign. Y is also 12. X is, I meant to say negative 12. X is negative 12. We got that up here. There it is, negative 12. And y is also negative 12. We want the product to be a max. You let x and y both be half of the sum. Negative 12 was half of negative 24. Okay, let's try one more. Suppose you have this triangle, a right triangle, 3, 4, and you want to put put in a rectangle. You want to put a rectangle. You want to put in the largest rectangle. You want to put in the largest rectangle. I think it's clear that you should put one side against the y-axis, one side against the x-axis, and the other point of importance is it should touch the line. Because why would you not want it to touch the line? In other words, why build one that size? Notice I didn't touch the line. You could have gone a little bit more and you would get more area. You definitely want to touch the line. In fact, one point determines the rectangle. If you pick, say, this point, your rectangle is determined. There it is. If you pick that point, then this here would be your rectangle. Now, if you pick any point inside, then that would be your rectangle. But if you want to get the largest, you had two options. You could have gone up to here, and you would have gained that much more area. Or, instead of going up, you could have gone to the right more. And then instead of only getting this area, you will get this extra. You definitely want to pick a point on the line to help you complete the rectangle. The question is, how do we get an equation involving that point? This point right here, like any point, is some xy. Now, let's put a coordinate system here. Let's suppose that was the origin. Suppose there's the origin. Alright. We have our x-axis, we have our y-axis. How long is this piece? It's going to be x. Because the x value right here is x. That is, when I look straight down, I better see x. And from 0 to x is x. Now, how tall is this? Same exact reason, it's y. So the area is x times y. We want to maximize this. Now there is another constraint. You have to, xy, it's just, xy is not just any old point. That is, it wasn't this point. For example, here's our triangle. If I pick this point and I call it xy, then our rectangle will be the same size. That is, the formula wouldn't change. It'll be x times y. But we shouldn't be picking a point like that. It's not on the line. So what we need to do is find the equation of the line. Because of course, that's going to talk about x and y's. Well, we know one point on the line. This point right here is 4, 0. And we know this point on the line is 0, 3. Because they told me that the height of the side of that triangle was 3. Okay. So we find the slope. From 0 to 3, the change in y from 0 to 3 is 3. Now what's the change in x? Well, if you go from 4 to 0, you went down 4. So the slope is -3/4. And we know that b, the y-intercept, is 3. So now we have the equation of the line. Y is equal to m x plus b. But excuse me, b is 3. So there's the equation of the line. Y is equal to -3/4 x plus 3. Oh, this is another way of writing y. That's another way of writing y. I'm going to plug it right there. So A is x times another way of writing y. And if we distribute, we get -3/4 x times another x, which is x squared, plus 3x. This is A, this is B. And since it's a negative quadratic, that extreme value we're going to find will be a max. And it happens when x is negative b over 2a. A is -3/4 and b is 3. So you get -3 divided by, here there's a little cancellation going on, divided by -3/2. If you work it out, that's 2. Okay, so x is 2. And y is going to be -3/2, -3/4, excuse me, times x plus 3, which is -3/2. 2 goes into 4 2 times, plus 3, which is 3/2. So x is 2 and y equals 3/2. You should go to 2 3/2. Okay, if this point right here is 2 3/2, you'll get the largest rectangle in there. You'll get the largest possible rectangle in there. Let's try one more. Suppose you have P feet of fencing, and you want to make a figure that looks like this. Anything you see is part of what you want to build. So basically, you want to build some kind of a pen that has 12 different areas, 12 different enclosures. You want to put one set of animals here, and maybe isolate the pig in here, and put some animals here, and some animals here, etc. You don't want them to mix and match. You decide who gets to hang out with one another, who gets to be in the same enclosure. Well, then what you need to do is you need to put a fence here, and a fence here, and a fence here, and another fence here, and a fence here, and here, and here, and here, and here. Okay, that's how many fences you need to put. And all you know is you have P feet of fencing. And you want to maximize the area. Well, if I call this X and I call this Y, well, the perimeter is how much fencing I need to buy. Well, going up and down, I need X feet here, and another X feet of fencing here, and here, and here. That is, I need 4X feet of fencing. plus the y's. 1y, 2y's, 3y's, and 4y's, and 5y's. This is how much fencing I need, and it's going to equal p feet. Now the area, of course, is x times y. And we want to minimize it. We want to first get it in terms of one variable. For example, I can get rid of y. I can get rid of x. I can bring the 5y over, and I have 4x is p minus 5y. Now divide by 4, and that gives me what x is. So a equals x times y, which is py over 4 minus 5y squared over 4. That's a, the number including the sign in front of the square term, and b, including the sign, the value in front of the linear term, the y term. So y should be negative b over twice a. And b is p over 4. And a is negative 5 over 4. Well, the first thing I might do is multiply by 4 over 4. So you get negative p, because by design the 4's cancel. So you're left with negative p. And here the 4's cancel. So you're left with 2 times negative 5, or negative 10, which is p over 10. And now, to get the x value, you know that x is p minus 5y's all over 4. So it's p minus 5 times y, which is p over 10 over 4. It's p minus p over 2. 5 goes into 10 2 times, over 4. If I double everything, I get 2p minus p, which of course is 1p over 8. Okay, so y is p over 10, and x is p over 8. Now, how might you see that more quickly? Well, half the perimeter goes for vertical fencing, and half the perimeter goes for horizontal fencing. So we have p over 2 for vertical, for the total vertical. But since we have 1, 2, 3, 4 verticals, I have to divide our available fencing for the vertical by 4. And that gives me p over 8 to answer. Half the perimeter, p over 2, is reserved for horizontal. But when it comes to horizontal, when I have p over 2, but each one, but I need a few of them. I need 1, 2, 3, 4, 5. For example, if you had 20 feet for the horizontal, and you needed to make 5 of them, you would divide by 5 to find out how long each y would be. You need 1 up here, you need 1 here, you need 1 here, 1 here, and 1 here. For example, if somebody gave you 20 feet of fencing, how would you figure out what length pieces to cut? And the answer is, you divide by 5. And you know what? When you divide this by 5, you get p over 10. It's always going to be that way. And that is the answer we got earlier. half the perimeter goes for horizontal, and half the perimeter goes for vertical. Teacher will probably want you to show your work, but at least he knows the answers pretty easily. For example, if you had you have the ocean here, and you need to build something that looks like this. Notice I didn't have to draw or put fencing along the water. That is, I'm only putting fencing here, 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 and here. Now, suppose the perimeter is 120 feet. So my question is, how much is X? How many feet go up and down? And how many feet left to right? Half the perimeter is reserved for up and down. It's reserved to build these three pieces. Well, if you have 60 feet and you need to make 3 equal lengths, you should let it be 20. That is, X should be 20. Take half the perimeter and divide it, 60, half the perimeter, and then divide it by the number of vertical pieces you need. Now for Y, we're going to take half the perimeter, which is still 60, and we're just going to divide it by 1. We're just drawing 1. We're just putting one piece left to right. Divide them by 1, you get 60. And that not only does this add up to 120, that is, you need 3 pieces at 20 and 1 piece at 60, and they do add up to your 120 available feet, but they also give you the largest area. That's the nice part. It gives you the largest area. It gives you the largest area. If you had to figure this out the long way, well, you need 3 X's. You need 1X, 2X, 3X, plus 1Y. And that's going to equal the total perimeter, 120. And we know the area is XY. So somehow we have to get rid of one of the variables. And we want to maximize our area. So if we bring this 3X over, you get excuse me. If you bring this 3X over, you get that 1Y, you get 1Y, positive 1Y, is 120 minus 3X. So I take this new way of writing Y, right there it goes. So A is X times another way of writing Y, that is, it's still XY, and this is 120X minus 3X squared. The number in front of X squared is A. The number in front of X is B. And we know X is negative B over 2 times A, which is 20. X is 20. And Y, by the way, that is what we got. And Y is 120 minus 3 X's. That is 120 minus 60. That is good old 60. And that's exactly what we found out Y to be using the shortcut method. Half the perimeter goes to the vertical pieces. The other half of the perimeter goes for horizontal. If you have 3 verticals, you have to divide the horizontal share, the vertical share, half of the perimeter, by 3. Okay, that completes this section.